So shall
Start.
I share?
Yes, yes, yeah. Okay, you start.
So my screen is visible. Hello.
Yeah, 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 visible. Yeah, tell me. Yeah. Mm.
Hello.
Yes, yes. Show me.
Sir, is it visible?
No, not visible. This one you open. First slide, it's not visible.
Yes, sir.
Second slide, you go to second slide.
Yes, sir.
Okay. Okay,
So,
sure.
good evening, everyone. Good evening, everyone. Myself, Shrubi Yadav. Uh, Today, I'm going to present my topic, DEMUX. So, moving towards the introduction of DEMUX, as we are seeing here the diagram of DEMUX. So DMUX is a digital circuit that distributes single input into signals of several output line based on the selected inputs. So it is called as a data distributor. So data distributor we are saying that because it has one input and many outputs. As seen in the diagram, we are giving one input as I and many select lines that is of 2 power n. So it has a one minute, sir. Sir, is it visible? Next slide.
The third one, next you go. Fourth one, introduction on fourth one you go.
Yes, sir.
Introduction only I can see.
So it has output as 2 power n and input as 1, select line as n. So from diagram we can see that it has n minus 1 select line. It is taken as n minus 1 because we are seeing that output here we has 2 power n minus 1. That means the select line will be n minus 1. Okay, so examples we can see that it has the broadcasting to different channels. From diagram we can understand that first we can see the single source where a desktop is connected to DMUX and DMUX is connected to some other different devices such as printer, fax machine, and color printer, pen printer. So here we can see how it is distributed. So data is distributed based on the select lines. As the select lines are selected, so here we are using having 4 outputs. So we will be having two select lines. So combination will be of 4, 0, 0, 0, 1, 1, 0, and 1, 1. So when 0, 0 is selected, we see here the laser printer will be selected. And when 0, 1 is selected, fax machine will be selected as it's a D1. Zero when 111 is selected, then its pen plotter is selected as it is given at the D3 point. So we can see that how data is distributed here according to the select lines and the combinations. Moving further, the types of DMUX. So DMUX has 4 types. 1:2, 1 is to 4, 1 is to 8, and 1 is to 16. As we have seen, the select line will be of n. So when 1 is to 2 demux is selected, so the select line will be 1. When 1 is to 4 data line is selected, so the select line will be 2. When 1 is to 8 demux is selected, the data line will be 3. And when 1 is to 16 is selected, so the select line will be 4. So how data is transferred or selected at the output lines, we can see here that if the according to the select lines. So if 0 0 is selected, the input will go and move towards first output as A. So A is selected. At second, we can see when select line will be of 0 and 1, that is B is 0 and A is 1. So the second output is selected, that is B. When third, so select line will be 0 1, so C is selected. And at last, when both are 1 1, so D is selected. This is how DMUX is working. So when according to the select lines, this is how the data is transferred. Moving towards the first DMUX type, that is 1 is to 2. 1 is to 2 DMUX has single input, two outputs, and one select line, as I mentioned before. So, seeing the diagram of this, input has D input and one select line, output as Y0 and Y1. So, we see the truth table of this. When select line is set to 0, then which output is selected? Y0. So, Y0 is 1 and Y1 is 0. When a select line is 1, so which data is selected? Y1. Y1 will be 1 and Y2 will be 0. So we got the expression as Y0 equals to S bar D and Y1 equals to SD. So we'll get the logic diagram as this. Okay, so logic diagram, we can see that Y0 is S bar. So we have given connected with NOT gate and then with AND gate. And for the Y1, S is in true state, so we have connected it directly. Moving towards 1 cross 4 demux, so it has an input of 1 and output 4. So the select line will be 2. So here we can see the block diagram of demux. Uh, Here the input will be D and output we will see that it will be Y0, Y1, Y2 and Y3 and select line will be 2. Here I have, I think, mentioned 1 cross 2 logic diagram, but we can say that if the output are 4, so the data will be Y0, Y1, Y2 and Y3. We can see from truth table. When first select line will, both the select line will have 0 0 combination, so which data will be selected? Y0. When it has 0 1, so Y1 will be selected. When it is 1 0, so Y3 will be selected. And it has 1 1, so last Y3 will be selected. So we can get the equations as Y0 equals to S1 bar S naught bar D, and Y1 equals to S1 bar S naught D, Y2 equals to S1 S naught bar D, and Y3 equals to S1 S naught D. So the logic diagram will be like this. So implementation of higher order mux to lower order mux, you can see here some steps. Step 1, we have to calculate the demux required by the dividing higher order mux to lower order mux. For example, we can see if we have taken 4 cross 1 cross 4 mux, and we have to implement using it 1 cross 2. So we will divide 4 by 2 because higher mux is 4 and lower mux is 2. Step 2, we will count and continue and divide it till we get 1, and adding on all the uh, combinations we get the demux and connect it at last. Moving towards designing of 1 cross 4 demux by using 1 cross 2 demux. So the number of input we'll get here is 1 and output as 4. Select line would be 2. So step 1, we will divide 4 by 2. So we'll get the second stage. And dividing further, we get 1 at first stage. So the number of demux required would be 3. So we can see here that first we have taken 1 cross 2 demux where input is D and select line will be S0, and connected further to with 1 cross 2 mux and other with 1 cross 2 mux. So the select line will be here common as S1, and the output data will be Y0, Y1 and Y2, Y3. And truth table is as follow. The select line S0 and S1, when it is 0, so Y0 is selected. When it's 0, 1, that is S1 is 0 and S0 is 1, so the Y1 data is selected. As S1 is 1 and S0 is 0, so Y2 is selected, and S1 and S0 both are 1, then Y3 is selected. Moving towards 1 cross 8 demux using 1 cross 2 and 1 cross 4 demux. Here the output will be 8 and select line will be 3. So we will follow all the steps till we get 1, and we get here as 3 stages. First we'll draw with 1 cross 2 demux, input taking as D, and S1 will be, and S1 and S0 will be common select line, and S2 will be the select line for the first demux. So here the output combinations will be 8 combinations, and truth table is also as follow. Moving towards the full adder using demux. We'll first see the circuit of full adder. In full adder we have 3 inputs, A, B and C in, and the output will be as sum and C out. So how we can draw this as with demux, we'll see here. First we'll draw the truth table and find out the combinations for sum and C out. So we'll take A, B, C as input and sum as output and C out as carry out. So we get the combinations and minterms here as sum A, B and C in is equals to minterm of 1, 2, 4 and 7, and C out minterms we get 3, 5, 6 and 7. So we can draw logic diagram from this. First we will take the 1 cross 8 demux. So input will be I, and it has 8 output combinations and 3 select lines, and select line will be A, B and C in. So according to the minterms we connect with sum and C out. That is 1, 2, 4, 7 outputs are collected with sum, and 3, 5, 6, 7 is connected with cout. So difference between the mux and demux we'll here. So multiplexer is a in our words we can say that it's multiple input and single output. That is, it's a data selector. And here we can say in our words demux is a multiple single input and multiple output. So it's a data distributor. So this circuit works as a digital switches multiplexer, and these switches works as digital circuit as demux. So these multiplexer, these circuits have multiple inputs and single output, as I said, and demux it has multiple outputs and single input, as I said before. And example we can see here as of multiplexer is 2 cross 1, 2 cross 1 cross 6, 16, 1 cross 8. And for demux we can see here as 1 cross 2, 1 cross 4, 1 cross 8, 1 cross 16 and more. Moving towards the advantages of demux and why we chose demux. By using demultiplexer, we can increase the efficiency of the com- communication system. So, for communication system, it's required as data routing for signal distributing, also for broadcasting some devices. More, we demultiplexer can be separate different signals from mixed signal also. So it can also separate different signals from mixed signals to streaming. Demultiplexer can decode the signals proceed by the multiplexer. So it can act as a decoder for multiplexer. That is, it works opposite as multiplexer works. So, and disadvantages of multiplexer, the use of demultiplexer can cause wastage of bandwidth. So its disadvantage is its use can waste bandwidth, and the synchronization of signals can create a delay in system. So delay is also created when we use demultiplexer. One more thing I want to add here is demultiplexer. We chose demultiplexer over we chose demultiplexer because we can decode the multiplexer, decode the mux here. So demultiplexer is working as a data separation also for mux. Thank you. Thank you, sir.